Okay, so we're going to talk about some of the trig function identities and how to use them. This is some of the most important stuff that you will ever learn in, or that you need to know for calculus and calculus. So these are the list of all the identities. The first 5 are pretty simple because you have to remember them to know just the simple tangent, cotangent, secant, cosecant, cotangent. So tangent is just sine over cosine, and cotangent is cosine over sine. And this makes sense because the cotangent, which you can see down here, is the reciprocal of the tangent. So just flipping these just makes sense. So then down here we have our secant and our cosecant. So the secant is 1 over the cosine and the cosecant is 1 over the sine. Those are pretty simple and most people already know those too. So down here, this is where it gets complicated. So sine squared of theta plus cosine squared of theta equals 1. No matter what theta is, or your angle, no matter what your angle is, it's going to equal 1. No matter whether it's 1 or a gazillion, it's going to equal 1. So this notation is kind of funky, and I will normally write it as sine theta squared plus cosine theta squared. That it means the exact same thing, and this notation that it's in sometimes just messes me up, so it's easier if I can see it like that. So then these two, you can memorize them, but if you don't want to, they actually just come from this one, but I'm not going to get into how they do that. Okay, so let's go ahead and move on to some important things to know when using these. So you should know, if you have the unit circle memorized, that all the points on the unit circle are always in this format: the cosine theta, comma, sine theta. So this is our x value and this is our y value. So this is important because if you know these using the positives and negatives, you can actually decide which quadrant that point comes from. So in quadrant 1, it's going to be x is going to be positive and y is going to be positive. In quadrant 2, x is going to be negative and y is going to be positive. And then in quadrant 3, x is going to be negative and y is going to be negative. And in quadrant 4, x is going to be positive and y is going to be negative. You can also take these to find the tangents. 2 negatives gives you a positive and a negative gives you a negative, a positive and a positive gives you a positive, and a positive and a negative gives you a positive. But we're not, actually yes, we are going to need to know that to do this. So let's get into some problems. So this is the simpler of the two, and it's telling us that the tangent of 3/4 is located in quadrant 3. So find the 6 trig functions of theta. So it's telling us that the tangent of theta is 3/4. So down here we can go ahead and plug that in as 3/4, and therefore we also know the cotangent, which is going to be 4/3, since that's just the reciprocal. And it's also telling us this is quadrant 3. So knowing that, we're going to have 2 negatives. So that means everything except the tangent and the cotangent is going to be negative. So we can go ahead and put those in so we don't forget them. So then when we do this, we can take the tangent squared theta plus 1 equals secant squared theta. Okay, so we know our tangent, and that's going to be 3/4. So we can take that and square it and add it to 1, and that should give us our secant of theta squared. Excuse me. Okay, so when we square a fraction, we just square the top and the bottom, so that gives us 9/16 plus, and you can go ahead and turn this into a fraction, 16 over 16, which gives us secant of theta squared. So then if we take these and add them, it gives us 25 over 16, which equals secant theta squared. So then we can take the square root of both sides, and that gives us plus or minus 5/4 equals secant of theta. Now, yes, you do have to add this plus or minus, but since you know that this is going to be in the third quadrant, and you know that in the third quadrant your secant is negative, you know that you're not going to use the positive answer, so it's just going to be negative 5/4. So negative 5 over 4. So then you can take the reciprocal of this and get your cosine, which is negative 4/5. So the next property we're going to use is sine squared theta plus cosine squared theta equals 1. So with this, you know that the sine of theta squared, which is what we're looking for, plus negative 4/5 squared is going to equal 1. So if we take this, the sine of theta squared, and we square this part, we get 16/25, and then this 1 is going to equal 25/25. So then we can take and move and subtract 16/25 from both sides, and then we get sine of theta squared equals 9/25. So then we can take the square root of both sides of this, and that'll give us the sine of theta equals plus or minus 3/5. But we know that we're in the third quadrant, so our sign is also going to be negative, so we can get rid of this positive answer and we just have negative 3/5. And then we can take the reciprocal of this and get negative 5/3 for our cosecant. So if they give you the quadrant, that's how you find the 6 trig functions of theta. So then sometimes they're not going to give you the quadrant, and you're going to have to find the quadrant yourself. So in an example like this, they're going to give us the sine is equal to 1/3, and note that this is positive, and the cosine is less than 0, which is going to be a negative answer, because anything less than 0 is negative. Okay, so the first thing to do is think, so if cosine of theta, sine of theta, we're going to have negative y values, no, positive y values, and negative x values. So using this, if we go back here, we can see that we are going to be in quadrant 2, because that gives us negative x values and positive y values. So let's go back over. So we are going to be in quadrant 2. And with that, we already know our sine value, which is going to be 1/3. So therefore we know our cosecant 2, which is going to be 3. And these are both going to be positive because it gives it to us positive, and we're in the second quadrant. So then the first identity that we're going to be using is sine squared theta plus cosine squared theta equals 1. So then if we rewrite that, that's going to be 1/3 squared plus cosine of theta squared. And again, you don't have to rewrite it like this. That just helps me see it, that it's being squared. That equals 1. So then we're just going to square the top and the bottom, which is going to give us 1/9 plus cosine of theta squared equals, we can go ahead and change this to 9/9. So then if we subtract 1/9 from both sides, that's going to give us the cosine of theta equals 8/9. Or the cosine squared of theta. Sorry, I almost forgot that. Do not forget that, because that is a very important step. So then you take this and take the square root of both sides, and that'll give us the cosine of theta equals the square root of 8 over the square root of 9, which can also be written 8/9, like that. So then what you want to do is take this and simplify the square roots as much as you can. So the square root of 8 is going to be 2 square roots of 2, and the square root of 9 is 3. So that will be our cosine value. So our cosine is, and we need to make sure it's actually going to be plus or minus, because we took the square root. So we need to make sure we check and see our cosine values are going to be negative. So we're going to get rid of the positive answer and just take the negative. So negative 2 square roots of 2 over 3. And then over here we know our secant is going to be the reciprocal of this. So what we're going to do is take 3 over square root of 8 and rationalize it. It's easier to rationalize if you just leave it unsimplified and then do it. So then take it, square root of 8 over square root of 8. And that's going to give us 3 square roots of 8 over 8. Then we can simplify this now, and that'll give us 6 square roots of 2 over 8. And that will simplify to 3 square roots of 2 over 4. So our secant is going to be negative 3 square roots of 2 over 4. Now for the next identity, we are going to use tangent of theta equals the sine of theta over the cosine of theta. Now if you wanted to, you could use cotangent equals cosine over sine, but I think the tangent's just easier to look at, so we're not going to use that one in this. So if we know that, we know our sine value is 1/3, and that's going to go over our cosine value, which again, to make this simpler, I'm just going to take negative square root of 8 over 3. So then that's going to equal, we just take the reciprocal of the bottom, that's going to equal 1/3 times 3 over negative square root of 8. So then our 3's are going to cancel, because we can cancel diagonally, and that's going to give us 1 over negative square root of 8. So what we can actually do is look at this, and since this is our tangent value, before we rationalize it, we can go ahead and say that the reciprocal of this is negative square root of 8. So then that equals negative 2 square roots of 2. So we can go ahead and put that in for our cotangent. And that's so we don't have to rationalize it, then take the reciprocal, then rationalize it again, just to get the same answer. So then we still do need to rationalize negative 1 square root of 8, which you can put the negative in the top or the bottom, it really doesn't matter. It's just, it looks better to have it in the top, I think. And then you put it over the square root of 8 over the square root of 8, and that's going to equal negative square root of 8 over 8, which will give us negative 2 square root of 2 over 8, which simplifies to negative square root of 2 over 4. So that's going to be our tangent. Square root of 2. Now you do need to check. So a negative and a positive equals a negative, okay, if you add those together. So you do need to check that actually no, if you multiply those together, my bad. So if you multiply those together, it's going to give you a negative. So then your tangents are going to be negative, which we have them negative down here, but you always want to make sure you check that, because that's another important part. If you don't have the negatives down here, then it's wrong, and it's not the right answer. So that is simple trig function identities.